Okay, students. So it's the network is working right now, and so I'm recording the class right now. So without further delay, let us start. So you can see here two questions. Those are basically preps for you, but there are some what you say hint for you. For the first question, uh, a shell burst on contact with the ground. The fragments fly in all direction with speed up to 30. So here is that maybe that shell, and it is bursting. So the fragments can go in all around the surroundings, and let us say that one portion of it is going in this way. A man standing at a distance 45 meters, so let's say the man is standing here, is in the danger for 30 seconds. Okay, so I have to find out the time for which the like thing is dangerous for the man. So basically I have to find out the time for what you say your projectile motion. So you know that t is equal to 2v sine theta by g. So we need theta because v we know that is 30, and the range is given 45. So using this range you can find out theta, and from there you can find out t. Okay, so this was the hint for this question. And the next question is, a projectile is projected at an angle 45 degree with an initial velocity u. The time t at which its horizontal velocity will be equal to the vertical velocity is dash. So this is easy, straightforward. You know that your horizontal velocity component is v cos theta, and your vertical velocity component is v sine theta, right? But you have to just correlate this, because see, you know that your horizontal velocity will not change because there is no acceleration in horizontal axis, but this uv will change because it is under influence of gravity. So when it is at the topmost point, uv will be 0, and in the initial position, like the start of the motion, uv will be v sine theta. So you have to find out a relationship regarding that, and then you have to compare these two. So these are two preps for you, find out by yourself. So what today I'm going to teach you is something a little bit challenging, but it's very useful, and it may be useful for your entrance exams. So the thing is inclined motion. So we have to find out inclined motion. That means the so let us draw something like this. So let's say we have this inclined plane, and then we have a projectile motion like this. Okay, so my drawing is very bad. Okay, let me undo this. Okay, so now how to find it? Let's say this angle is my theta, and this angle, that means the angle at which your projectile is thrown, to be alpha. Okay, now let us talk about it, how to find out the distance, the height, and all those things like this, and the time, basically the time. So in this case, what we are going to do, we are not going to take these as x-axis and these as y-axis, because in this case we have some different situation. So instead what we will do, we will take this one as our y-axis and this one as our x-axis instead. Okay, now the main trick is that when the projectile will be in this or any other like arbitrary position, the gravity will be working just like this down, right? So what I can do now, I can think this motion to be such that x is the horizontal plane. So what we have to do, we will split this g, because g is an acceleration which is a vector quantity, right? So what we will do, we will split the value of g in both cases. So one will be this, another will be this. So if this is g, now your question will be ki what will be this angle? So this angle will be your theta. Okay, this angle will be your theta. Now why this angle will be your theta? If you shift this whole thing here like this, so you can see that this is 90 degrees. So this g is actually perpendicular to our this axis. Let's say this is x prime, so with x prime. Now this is 90, so this will be my 90 minus theta, right? And this one will be then, because the total one is 90, so this one has to be theta. So that's why this angle is my theta. Okay, now let us now see one thing. So this component will be g cos theta, and this component is that is working in horizontal x-axis right now, that is g sin theta. Also you can see one thing, that the if my total velocity is v, so vx, that is the component of v along x-axis, is my v cos alpha, and my component along y-axis is v sin alpha. Okay, chalo, let us now calculate everything like that. Now one thing you can see, that in our previous case, when we were dealing with a simple projectile motion, the acceleration in horizontal axis was 0, but in this case you can see g sin theta, this term is there, right? And this is working in the opposite side of x. So we can say that in this case my acceleration along x-axis is my minus g sin theta, and acceleration in y-axis, now gravity, this you can see that in y-axis also this g cos theta, this part is working against y-axis, right? So that means your what you say g cos theta is working against y, so it's retardation, so it will be g cos theta. Okay, so now we know the accelerations and we also know the initial velocities. Now similarly, when this projectile, so I'm changing the color so that you can understand, when this projectile will come at the highest point, this vy, that means the y component of your velocity, will become 0, right? So if we calculate now all the things, so I am segregating here and I am making here two different sections. One is for x motion, that is motion along x-axis, and one is for y motion, that is motion along y-axis. Now if you talk about motion in x-axis, so we can see that if this distance I take as r, that is my range. So my range R can be written as rs equal to ut plus half at square, right? So ut, so I'm writing all the formula at first, then I will substitute the value. So I can write r equal to ut. So I don't know time, so I have to find out time in order to put all the stuff. So what is my u? My u is v cos theta, right? Cos alpha, sorry, cos alpha, v cos alpha. So I can write here v cos alpha t plus, now this will not be plus because a is my minus sine theta, right? So what I will write here, I will write here minus g sine theta by 2 into t square. T square is there, so I need t. Without t I cannot calculate anything. Now you can see in y axis I know one formula, that is v equal to u plus at, and I also know that when the projectile will go in the top position, that is my this position, my velocity will become 0. So my final initial velocity was v sine alpha, so it was v sine alpha. My acceleration in this y direction is minus g cos theta, so it is now minus g cos theta t. So I can find out t is equal to v sine alpha by g cos theta. Now this time I am writing here t, so I should write here t prime, because these two times are not same, because this is the half of this time, because this t is the total time, because for range the projectile has to come from this position to this position, so that means total time has to be taken care of. But with this one t prime, I am basically making you realize about the time taken from the projectile to go from this point to this point only. So we have seen in the last time also, the time taken to reach from this point to this point is the same as to time taken to reach from this point to this point. So what I can do, basically I can multiply 2 with it in order to get the total time. So total time is 2 into t prime, that is 2v sine alpha by g cos theta. Now if you put this t, so this t is basically this t here, okay? So I can write this big T as a small t, because I will substitute here. So basically one thing is derivated already, that is this one. So this one of the motion to find out the total flight time. So we have gotten this. Now to find out the range in this case, so to find out the range I have to put all the values here. So it will be v cos alpha into 2v sine alpha by g cos theta minus g sine theta by 2, and I have here 4v square sine square alpha by g square cos square theta. So it's basically a little bit tough to do it, not tough, like I don't have any space here, so you can do it to find out. Let me write then also. Okay, so r will be is equal to, so 2v square, so 2 sine alpha cos okay, one more thing I should see here. Okay, 2 sine alpha cos alpha, that will be sine 2 alpha. So I can write here v square sine 2 alpha by g cos theta. then I have here minus, so this g and this one gone, so this 2 and this is 2, so we have here v square sine theta, v square sine theta sine alpha, sine square alpha, okay, sine square alpha divided by g cos square theta, something like this. Okay, so this is the procedure to find out. Now we can also find out the h, that is the top portion. So to find h we can use that vertical way, vertical vertical y motion. So we can write s equal to ut plus half at square, that also, and we can also use v square equal to u square minus 2gh. So if we use that, it will be much easier. So what we will do, v square equal to u square plus 2gh, so or 2ah, this is the general formula. Instead that we will use, now we know that at the topmost point the velocity will be 0 and our initial velocity is v sine alpha. So we can write this equal to v square sine square alpha minus 2. Now my a in y-axis, that is ay, is g cos theta minus g cos theta. So I'll write here minus g cos theta h. So I can find h to be v square sine square alpha by 2g cos theta. So I have also gotten the value of h in this case and r in this case. Fine. So this you have to do. So basically what I have done, the principle is that I have to change my x and y axis in such order so that the situation will be very much easier for me to calculate, and the g, I have to split the components of g to create the situation much more simpler. Now if we say that the situation is something like this, and from top portion you are now projecting something, so you can understand it will go like this, and similarly this is theta, and if this is my angle alpha. So in this case also what I have to do, I have to take this as x-axis and this one as my y-axis. Okay, so once I take these and x, and this is as x and this is as y-axis, I also have to define my g components. So g is working downside, but now I can see that if I take two components, so this will be your theta in this case. So this one will be your g cos theta component, and this will be your g sin theta component. So what we have to do, we have to again see that if the velocity is v, so my vx will be v cos alpha and vy will be v sin alpha, and also my accelerations will be as ax will be g sin theta. Why this time there is no negative sign? Because you can see that in the direction x is increasing, in the same direction g sin theta is working as well. So g sin theta is aiding the motion. Okay, that's why it's positive. Ay will be as usual minus g cos theta. So in the similar treatment what we have done in this case, that x motion and y motion we have created. In the same situation will be here also, but only some sign will be changed for x motion. Like you can see here we have used minus, so we will use plus in that case. So what will be the situation will be that you have your x motion, you have your y motion, and then you have to, so this will be your range. Let's say the x distance is your range that is working here, and your height is, the maximum height will be shown like this. So in this point, let's say the maximum height will be there. So the treatment is same. Basically you just have to remember these things, so you can get very easily the what you say, the value of total time, the value of this range, and the value of your height. So in this case also you can see that let me do this, that is v equal to, okay, let me do this with this pen, this ink. So you know that v is equal to u plus at, but in case of vertical motion at the top portion this will be 0. My u in the vertical motion is vy, that is v sine alpha, and at I have a that in y-axis minus g cos theta, so minus g cos theta into t. So from here I can find out easily that time t equal to v sine alpha by g cos theta. So my total time will be the twice of it, because the time taken to reach from this point to this point is the same as the time taken to go from this point to this point. So and this proof we have seen in the last video. So this will be 2v sine alpha by g cos theta, right? So total time I have found out, and then the r will be as r is equal to ut plus half a t square. So my ut in this case is vx, that is v cos alpha, so v cos alpha t, plus in this case because ax is g sine theta, so at square, so half into g sine theta, so sine theta into t square. So this t is basically the big T, so I will write here big T. So if you just put the value of this big T here, you will get the value of range, and your height will be h, that will be that we can find out that from that formula, that is v square equal to u square minus 2gh, or in this case let's ah. So I know that v square at the topmost point, the velocity will be 0, that is the vertical velocity will be 0. U is the vertical initial velocity, that is my vy, that is v sine alpha minus, now y, this was plus like general formula, but now it will be minus because my ay, that is acceleration working in y-axis, is minus g cos theta h. So my h will be v square sine square alpha by 2g cos theta. So this will be my h. Now you can remember one thing, that in this case also, and in the last, that is this going upside, this case also, the value of h is same, right? And the value of h for normal motion, that means for normal projectile motion, this was v square sine square theta by, or alpha by 2g. So only a cos theta part is there, Okay, so that you can remember for your entrance exam. Okay, and if you see, look at the time, so the normal formula for time was t equal to 2v sine theta, in this case sine alpha, by g. But here also one cos theta term has come, you can see. So this was the normal one, that is for this motion, and this is for the inclined motion, right? So this you can remember for your entrance exam, then you don't need to derive. Okay, and range, I don't think it will be given, it will be asked in the question. So the time is basically important, and the height. So only a cos theta is coming in the denominator, just remember this. So this was the class for today, and your prep is given. This one I have given the hint also, so try to do this prep. And your code word for the next class is picnic. So bye bye for today, see you in my next class.